Okay, in day 2 of this unit, we are going to do two things. We are going to learn how to do unit conversions using a tool called factor label or dimensional analysis. And then the second thing we're going to use is a density formula to be able to calculate density, mass, and volume. So let's go over the first topic, which is to learn how to convert units. Okay. There are two main sets of, or two main systems for measurement in the world today. One is called the metric system, or the SI system, and one is called the English system. In the United States, we mostly use the English system. Things like you're familiar with, like races are measured in miles, things are measured in feet, square footage, inches. However, most of the world uses the metric system, okay, which is this top system. Meters, kilometers, kilograms, grams, those types of units. And if you look how to convert from big units to small units in the metric system, you can see that it's all by factors of 10, which is very easy to do. However, if you look at the English system down below, to go between, for example, a mile and a yard, you would have to multiply by 1760. To go from a yard to a foot, you would have to multiply by 3. So the numbers are just not as easy as the metric system. However, we do have to know how to go between English to metric, metric to English, in order to be able to travel and to be able to, do chemistry problems. So the first thing I wanted to show you is we're going to talk about the metric system a little bit, just the metric system. Okay, so this is metric, what we're doing. And the way the metric system is broken down is that it consists of what's called a base unit and then a prefix. So when you look at the word, it will be a prefix combined with a base unit, okay? And the base unit will usually be, we're not going to look at time right now, one of these three. So for example, if you're weighing something, the base unit is going to be the gram. That's the unit, the base unit of mass in the metric system. And the symbol for that is little g. If you're measuring volume, right, that the base unit is liters, and that is little l. If you're measuring length, the base unit is meter, and that unit is little m. And you've got to know by heart these three base units especially, as well as their symbols, G, L, and M. Okay? So now that you understand the base units for mass, volume, and length, as well as their symbols, we're going to talk about the prefixes that go along with them. Okay, and there's a way to remember all the prefixes. Okay, I'm going to write it down for you, and then I'll probably erase it the way that I have on here the number. But it is King Henry died by drinking chocolate milk Monday night partying. Okay, King Henry died by drinking chocolate milk Monday night partying. Okay, so write that mnemonic statement down in your notes, and then make sure you underline each of the capital letters because they are going to be the important part of our number line. Okay? So pause the video, write that down, and then I'm going to erase that. Okay. Now, We have our base units, grams, meters, and liters. Okay, base, I'm going to put, we have a couple more things on the right, so I'm going to put the I'm a little bit off center. It's going to be our base unit right here. Okay, and remember a base unit is going to be grams for mass, L for volume, liters, and M for length, which is meters. Okay, now let's think about our mnemonic type. Our first prefix is K, king, which is kilo. Okay, hecta, King Henry, hecta, die, deca, buy, base unit, drinking, deci, chocolate, centi, milk, milli. Monday is going to be micro, which is the bamboo symbol. We'll talk more about that in a minute. Night, which is a nano. Partying, which is pico, P for pico. Okay, now before we fill in the number line, I'm going to have you look at this next page to write them all down. So these are the prefixes. King Henry died by drinking chocolate milk Monday night partying. So make sure you pause this video to make sure you have all the prefixes, their symbols, as well as their longhand so you know what they are. Okay, so get them down right now. Okay, and we're not going to worry about seconds right now. We just have grams, liters. Okay, so let's go back. Now that you've written it down, let's go back to our number line. You can see the shorthand for the prefixes. Kilo, hecta, deca, base unit, deci, centi, meter, milli, excuse me, micro, nano, pico. Now what you have to know, and I'm going to do this in blue, is that there is 10 between each of these prefixes. 10, a factor of 10. Okay, until you get past milli. Okay, then there's 1,000 between. So 10 to the third, 10 to the third, 10 to the third. Okay, so there's 1,000 between milli and micro, micro and nano, nano and pico. Okay, so that shows you the divisions between. Okay. Now another thing is what we're going to do is if you go from left to right, so a big unit to a small unit, you are going to basically multiply, okay, or the factor of 10 is going to go on top of what's called a factor label, which we haven't done yet. You go right to left, you're going to divide, or that number is going to go on the bottom of your factor label, which we haven't gone over yet. We will. Just write this down for now. Okay. And remember what's going to happen is that you're going to put prefix with base units. So for example, centimeter, kilogram. Okay, it's going to have a prefix and a base unit. Prefix and a base unit. Or can just be the base unit, meters, liters. It could be micrograms. Okay, so that's basically the number line for the metric system and how the prefix systems work with the 3 units I've taught you. Okay, now before we continue, I want to talk about the tool we're going to use, okay? It's called factor label or dimensional analysis. Same thing, okay? So the reason we do this is because in math, you're used to using numbers, just numbers, 1, 2, 10, 12. In chemistry, we use quantities, which means a quantity is a number and a unit. 100 is a number. 100 kilograms is a quantity. Okay, in chemistry, we don't deal with just numbers. There's always a unit. So this is what we're dealing with in chemistry. Okay, and sometimes you have to convert between units. How many seconds are in a day? How many inches are in a centimeter? If you're going 50 miles per hour, how many meters per second are you traveling? You've got to have a method to convert between units. Okay, well, how does factor label work? Okay, well, it's going to involve easy math, multiplication and division. Okay, it's also you're gonna perform what's called a conversion. And what to do that, you're gonna need what's called a conversion factor. Conversion factors are made from two terms that describe the same or equivalent amount. For example, 1 dozen is 12. 12 inches is a foot. 1 mile is 5,280 feet. Okay. Now, where are you going to find some of these conversions? They are on your blue reference sheet. Okay. Now, it may not be blue on your in your list of reference sheets, but we'll call it the blue reference sheet, and it will have your English conversion. Okay, so those are all English units. Okay, so you'll get some of those conversions from the reference sheet. Some of those conversions, like the metric system, you will have to know your number line. Okay. Okay. Now here's the main tool of factor label. We call it railroad track. Okay. And we start with that. Then what always goes on the top left of the railroad tracks, we put our given. Okay, now remember we're in chemistry, so it's always a number and the unit. Got to be both. The number and the unit. Now, what you know is going to go on the bottom. Okay? And it's going to be the same units as the given, so we can cancel them out. So it's going to be the given unit. What you need, what you're looking for, is going to go on the top. Okay? And what will happen is you're going to cancel out these units with these units so that you end up with the need, which is the number and the units that you need. Okay? One thing about factor label, on the top, it's all multiply, and on the bottom, it's all divide. Okay, so we're going to do examples using this factor label. So you may not understand it yet, and that's okay. Just keep in mind, have this ready. The given, which is the number and the unit, will go on the top left. What you know is going to go on the bottom to cancel out the given unit. And what you need, the new unit, is going to go on top. Okay? So let's start with a simple example because it's the only way to do it. Okay, so first, let's read the problem out loud. How many cups are in 4.5 pints? Okay, well, the first thing you have to do, since you don't know this, is look on your blue reference sheet and figure out how many pints are a cup or how many cups are a pint. And if you look on that reference sheet, if you want to pause and get it out, you'll find that 2 cups equals 1 pint. Okay, and this is going to be what's called your conversion factor. So if I go back here to this other slide, I probably should have said this. I'll circle it in green. When we talked about using a conversion factor, this is going to be what your conversion factor is going to look like. It's going to be 2 equivalent quantities. Okay, so this right here is our conversion factor, and I'm going to show you how to put it in factor label. And it's very simple if you watch how things cancel out. Okay, so let's put our same stuff out. What goes in the top left? This is where you would yell out given. Okay, so remember it's a number. The only number given is this right here in the problem. 4.5 times. So it's a number and a unit. Now this right here is where my conversion factor is going to go. This right here is where my conversion factor is going to go. Okay, now the goal is to cancel out the given units, put the new units. So pints is going up there, I want pints canceling out down here. And I want cup. So cup is going up here. Now I have to look at this conversion factor and match the numbers with the units. So 2 cups, 2 goes to the cups, 1 goes to the pints. Okay. And now I'm going to take 4.5, multiply by 2. So remember, everything across is multiply, everything under is divide. So if I was writing this units in my calculator, it would be 4.5 times 2 divided by 1. That's how it would be in my calculator. So that would be 9. Okay, and then I got to put the units because I'm dealing in quantities, not just numbers. So watch how the units cancel out. Pint will actually cancel out with pint, leaving the unit of cups. Okay, now let's talk about significant figures. Usually we're given for significant figures. All English units have an infinite number of significant figures, meaning they are what is called exact numbers. So for this, we do not have significant figures for the English unit conversion, and I'll explain more about that in class. So all I'm looking at is, since I'm only multiplying and dividing, I'm counting the significant figures that are given, and it's 2. So I have to make the answer have 2 significant zeros. Excuse me, 2 significant figures. So I'm going to add 1 trailing 0 to make 2 significant figures, and that's my final answer. Okay. If you're confused on the significant figures with the math, we'll work on that in class later. Let's just get the factor label down, and we can get, as long as you get the 9 for now and the cups, we're good. Let's do another example. Now this is going to be a little tricky because now we're using the metric number line. Okay, and I'm going to show you how to use the metric number line with factor label. Okay, so the question is, how many centimeters are in 355 millimeters? Okay, so let's set up the factor label. Okay, the given goes here with 355 millimeters. And then I need to know my conversion factor. So we want to go from millimeters to centimeters. So I know I want to cancel out the millimeters, so that's going to go down here. And I want centimeters up top. That's what I want. So I got to get a conversion factor to go from millimeters to centimeters. So what I'm going to do is I'm going to go back to my number line that I already created for you guys, and you could have one in front of you. And I need to circle where I'm going. I'm going to do it in fluorescent so you can see it, okay? But I want to go from millimeter to centimeter. So this is milli, and this is centi, okay? So I'm going from this dot, and I'm jumping to a bigger unit to here. And I'm doing it by a factor of 10, okay? Now, since I am going to the left on my number line, I am going to put the number on the bottom of my factor labeling. Okay, so since I'm going from milli to centy, and it's a factor of 10 between it, I am going to put the 10 on the bottom of the factor label. So let's go back. Okay, and I'm going to put that number 10 milliliters is 1 centimeter. And if you put the 10 on the bottom, 1 is always the other number. Okay, so if 10 went on the top, 1 would always be in the on the other block. Okay, and that's how you use the number line in factor label. Okay, and then you can see that the millimeters is going to cancel out, leaving us with the centimeters, which is what we want. So to do the math, 355 times 1 divided by 10 is going to be 35.5 centimeters. Okay. Now, centimeters in the metric system are all also perfect numbers, exact, infinite number of sig figs. So once again, all I'm counting for sig figs is that beginning number. So it's 3 sig figs, so I leave my answer in 3 sig figs. Now here's a challenge problem. You can actually use two-step factor label to take it to the next level and go from 355 millimeters to inches. See if you can do this two-step problem on your own, and when you come to class the next day, we'll solve it in class and I'll show you. See if you can get it yourself though. Okay, I'll give you a clue. The answer is 14.0 inches. See if you can get that. Okay, so now we've practiced a little bit of factor label. We'll practice more in class. I'm going to teach you one more thing before I end this video, and that is just a simple formula called density. Density is a property that we look at when we look at compounds and elements and things like that. And it's measured as mass over volume. So that is the formula of density. And it is one of the first formulas, and I'm calling it your yellow reference sheet because when we give them out in class, they're yellow. It's on the formula page on page 3, and it's mass over volume is density. Okay, and you can see the units of density are grams per centimeter cubed for solids, grams per milliliter for liquids, and gram per liter for gases. Okay, you'll see in this class mostly we'll be using gram per milliliter for a liquid or gram per centimeter cube for a solid. What I'm going to do now, excuse me, just to show you one conversion factor that's good to have written down is that 1 centimeter cubed is equal to 1 milliliter, excuse me. 1 centimeter cubed is equal to 1 milliliter. Okay. Now, just a little bit about volume. If they don't give you the volume, a lot of times you have like an irregular shape where you really have a difficult time measuring the volume. So it's not a perfect cube where you can use length times width times height, or a perfect sphere. So there's something called, okay? And what you can do is take a container with an initial level of water, as shown here, add your object, and measure the difference in water level. So for example, in this case, and we call this displacement loss. Okay, in this case, we start off with, let's see, see, we're about maybe 12. Let's say we start with 12. Let's say we start with 12 milliliters of water here. And we end up with, let's say we end up with about 22 milliliters as our final after we put our shape in. What would be the volume of that shape? Okay, well, what you would do is you would take your 22 minus your 12, and the shape volume would be 10 milliliters. So that's called displacement volume. Okay, now we're going to do a couple example problems on how to calculate density. What is the density of a piece of metal if the mass of the metal is 562 grams? It occupies 44.9 milliliters. Okay, well, you have to underline your givens in the column. You got mass and you got volume. And you know density is mass over volume. So you're just simply going to put 562 grams divided by 44.9 milliliters, divided in your calculator, pointer, and you get 12.5, and then the units over to mass over volume, grams per milliliter. Remember, it's quantity, not just a number. And since it's division, if you look at the sig figs, 562 has 3 sig figs, 44.9 has 3, so you're going to leave it in 3 sig figs. Example 2, now you're given the density. If the density of a liquid mercury is 13.0 grams per milliliter, what is the mass of 35 milliliters of a sample of mercury? Okay, so you're given density is mass over volume. You're given the density. You're given the volume. You need to solve for the mass. Okay? So you need to isolate the variable, which is the mass. So what I do in this case is I just put this over 1, and then I start cross multiplying. So I take these 9. So what I end up with is density times volume equals mass. Okay, now I have mass by itself. And you'll watch and see the units work out as well. So we have 13.0. Make sure you write the number and the units when you do this math. Don't just say 13 times 35 milliliters. Okay, look at the units. Milliliters canceling out, and we're left with grams, which is what we want. Multiply the two numbers, and you end up with 476 grams. I might have done this math a little wrong. Hold on 1 second. 13 times 35, 455, excuse me. I had a typo. 455 grams. Now, that's the right units. Let's look at the sig figs. Okay, we're multiplying, so we're just counting. We have 3 sig figs here because we have a final 0 after the decimal, and we have 2 here. That means we have to make this into 2 sig figs. So we could make it just 460, which has 4 sig figs, or you could make it 4.6 times 10 to the second grams. And again, don't worry too much about the sig figs. Just make sure you understand how to do the formulas right now. We can worry about sig figs in class. Okay, last problem. What volume will 45 grams of an unknown gas occupy if the density of the gas is 2.26 grams per liter? Okay, well now you have density and you have mass. Okay, so you have density and you have mass. So let's look at our formula. Density is mass over volume. Okay, we want volume, so we want to rearrange this equation. Let's put this over 1 and let's go to cross multiply. Get that v out of the denominator. Okay, so you get v times v equals m. Now you're going to divide both sides by v. Cross that out, and you get v equals m over d. That's our equation we're going to use. Okay, so if you need to rewind that to see how I got m over d, you can rewind that and watch it again. Okay, so now we have v equals m over d. I'm going to just work over here. So that's going to be 45 grams over 2.26 grams per liter. And 19.9 liters. Okay, and the sig figs, the top number has 3, the bottom has 3, and we'll leave the answer in 3. Okay, if you have grams over grams per liter, what's happening is the grams cancel out and the liter flips to the very top. Okay, that's the end of this video. If you need to watch any of the math slower, just rewind it or pause it so you can figure it out. Looking forward to tomorrow.